Okay, we're going to continue 6-1. We did like a little intro on Friday. Do you remember that? Okay, well, you should have watched the video, though, right? If you're not here, that's what you should do, is watch the video on it. But if you didn't, I'm going to review briefly on it. So we talked about different types. Is that the test? Yeah. Thanks. All right. We talked about different types of quadrilaterals. One, we're going to talk about a lot more specifically later on. But right now, we just kind of talked about the definition of this. Do you remember what it's a quadrilateral? By the way, what does it mean to be a quadrilateral? Four sides, that's right. So what was the first type of quadrilateral that we talked about? A parallel what? O-gram. Good. It's a parallelogram. All right? And I'll just draw it by hand here. This is kind of what a parallelogram looks like. So what do we know about a parallelogram? Just by the definition. What does the definition of a parallelogram basically say? It's a quadrilateral, okay, which means it's got four sides, but with what specifically? Both pairs of opposite sides are what? Not by definition. They're parallel to each other. Because look in the word, parallel, right? It's a parallelogram. So it's a figure that's got something to do with parallel, doesn't it? So what's parallel? The opposite what? The opposite sides, right? So the opposite sides are parallel. So you got two pair. We're going to talk about something in a few minutes here. You got two pairs of opposite sides that are parallel, right? There's one side, right? One opposite side or pair of opposite sides that are parallel. And then you got these two are opposite and they're parallel. That's what a parallelogram is. It's a four-sided figure, a quadrilateral with both pairs of opposite sides parallel. Make sense? All right. Then we got a little bit more specific. We had three things that are parallelograms, specific type of parallelograms. Okay, one was a rectangle. What did we say about a rectangle? Again, I'll just draw. It's a parallelogram, that's true. So a rectangle is a parallelogram with what, though? Just put it right there. Four what? Right sides? Right angles, good. Okay, with four right angles. So that means all four of these angles here are right angles, and that's a rectangle. Now, what do I know about the opposite sides? Since it's a parallelogram, what do I know about the opposite sides of a rectangle? Come on, listen. I don't think you're trying to think. Are we trying to think? I think we're just sitting there writing stuff down and listening to me go, wow, 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 wow. That's all I think. So listen, they're parallel. Because look, since a rectangle is a parallelogram, what's true about the opposite sides? Well, what's true about the opposite sides of any parallelogram? No, they're parallel. By definition, they're parallel to each other. So, right, the opposite sides of a rectangle must also be what? Parallel to each other. Now, it is true. Some of you guys said the opposite sides are equal. That's true, but we haven't even mentioned that yet. We're going to mention that some other time, all right? Not today. Everybody with me? We're going to talk about that some other time. But by definition, the opposite sides are parallel, okay? Now, it is true. That's a sneak preview, all right, that the opposite sides are also equal to each other. But we haven't mentioned that, though, all right? So let's not even talk about that right now. We are going to talk about it later, though. We got it? Okay. What was the other type of parallelogram we talked about? We talked about it, and it starts with an R as well. That's a rhombus. What did I know about a rhombus? Okay, that it is a parallelogram. That's true. With four what sides? Okay, well, all four sides aren't parallel. You got two pairs of parallel sides, but all four sides are equal to each other. So a rhombus, it's a parallelogram, okay, but it's a parallelogram with all four equal sides. We talked about this the other day. If a rectangle and a rhombus got married and they had a kid, then what would they have? It would be a what? A square. Okay? So, watch this. What's a square? A square is a rectangle. So that means all four angles are right angles since it's a rectangle, but a square is also a what? Come on. Watch my reasoning, my line of reasoning. Okay? I'm trying to lead you very easily, but you guys are all over the place. Okay, just wait. Let me do this again. I said a square is a rectangle because a square has all four right angles, correct? A square is also a what? A rhombus. Okay? Right? I went rectangle, then I went rhombus. A square is also a rhombus because what's true about all four sides of a square? They're all equal to each other. So look, a square is a combination of a rectangle and a rhombus. Okay? That's right. See? The dad is the right angles and the mom is the equal sides, or vice versa. Okay? Everybody got it? So that's what a square is. Yeah, not technically. I mean, you wouldn't see that in a geometry book. Listen. Listen. Guys, would you let me? Would you please let me speak? So you wouldn't see this in a geometry book. You would not see rectangle plus rhombus. You wouldn't talk about it, if it had a kid or anything. I'm just trying to make it a little easier for you to understand. Okay, that's all I'm trying to do. Dumbing it down is not. I'm just trying to get you to understand that a square is a combination of a rectangle and a rhombus. That's all I want you to see. Oh, that's okay. That's obvious. Well, yeah, for some it's obvious, not for everybody. Okay, so there you go. Now, there was one other one. See, these are all parallelograms. See, I put that arrow right there? All three of these are parallelograms. The next thing that we talked about on Friday is not a parallelogram. It's a kite. I'm just going to draw it freehand. Okay. It's not perfect, but it's close enough. This is a kite. And what do I know right now about a kite? I'm going to learn other things about a kite later on in another section. But right now, the only thing that I know about a kite is that these consecutive sides, what does that mean to be consecutive? They're next to each other, okay? You have two pairs of equal consecutive sides. So if these two are equal to each other, then what? That's right. These two right here are equal to each other, okay? These two are not equal to each other. You got it? All right? So you got two pairs of equal consecutive sides. What about the sides that are opposite each other? They are not equal. See, this one and this one are opposite to each other. They are not equal to each other. Make sense? So that is a kite. And that's really all we know about a kite. We're going to learn more things about all these things in another lesson. I forget what lesson it is. It's probably coming up pretty soon. It might be the next lesson. I just don't remember off the top of my head. But we're going to learn more things about a rectangle, a rhombus, and a square than just the definitions. All right? There are certain things that are true. Remember, you guys kept on saying the opposite sides are equal? That's one thing that we're going to learn about a parallelogram. We're going to learn it in another lesson. All right? Now, that's where we ended up Friday. So there was one more thing that we didn't have time to get to on Friday, and that is this. You probably heard it before, but you probably don't know really much about it at all. Have you ever heard that word trapezoid? Yeah, you've probably seen that before. But my guess is, and it's nothing against you guys, but you probably don't know anything about a trapezoid. But since it's under this lesson, what's this lesson called? Classifying what? Quadrilaterals. So you should know, or you should just take a wild guess, that you know one thing about a trapezoid. What would that be? It's a three sides. Why would I put a three-sided figure here when we're talking about classifying? It's a quadrilateral. It's a quadrilateral. Okay? So, look, classifying. I don't know if I liked it better when you guys just had your heads on the desk and were completely quiet. Or, I mean, it's nice that you're awake and you're participating, but we got to participate in a little bit more of a organized manner, okay? I'm not going to force you to raise your hand every time you want to say something, but let's just, you can say something. You can answer me if I have if I ask a question. I don't mind that at all. And I appreciate your enthusiasm. I do. But we got to contain it just a little bit better. All right. So listen, since this whole lesson is about quadrilaterals, what do you think might be true about a trapezoid? It's a quadrilateral. That's right. It's a quadrilateral. Everybody got that? Okay. Let me draw a trapezoid for you. This is just a general, everyday, nothing super special trapezoid. Okay. What does it look like those two lines might be? They're definitely not equal to each other. Nah, come on. What does it like? What does it just look like? Look at them. They're perpendicular? They're not perpendicular. Perpendicular means it makes a right angle. They don't make a right angle. So I heard it. Somebody said it. They're parallel to each other. Okay, you gotta say it louder. I didn't hear you. I was looking for it. So look, these are parallel. These are not parallel. Would you agree? Everybody see that? What do you think I just drew? Take a wild guess. Very good. It's a trapezoid. Since the word's right there and I'm drawing it, that would be a trapezoid. It doesn't have to look exactly like this. But one thing has to be true. Everybody watch. Remember those first two lines that I drew? Everybody listening? Those first two lines that I drew, what did I say were true about those? They're parallel. How do I show that two things are parallel? I put the arrows. Okay? So a trapezoid is a four-sided figure which we call a what? Quadrilateral. So it's a quadrilateral with exactly, I'm going to underline it, exactly one pair of parallel sides. That's right. Of parallel sides. Okay? Exactly, which means not at least, right? Not more than one. What? Exactly one. All right? And where are the parallel sides? This top one and this bottom one. Doesn't always have to be like that. I mean, you could. I mean, a lot of times that we draw these, it'll look like this, but you could always draw it like this, couldn't you? You could draw it like that. All right? It could be slanted in all kinds of different ways. But when we first learn how to do these things, we try to make it pretty easy, and we just draw it like this. So this is a what? Trapezoid. How do you know it's a trapezoid? Because you have what? You have one pair of parallel sides, which means what must, how do I say this? What's not true about these two sides, this left and the right side? They're not parallel. Exactly right. Okay, they're not parallel. The top and bottom are, okay, and the left and right are not. Sean, what do you need? What are you looking for? Pencil? Or are you just taking notes? You can. Oh, you're doing the test? Quiz? Oh, it just broke. You need a pen? I got a pen. Do I have a pen up there? All right, make sure I get this back. Here. You're welcome. Make sure I get it back. All right, here we go. We got a couple of things to explain about this, and then we'll do an example, and we will be finished for the day. All right, might even finish early. So the two parallel sides, we give special names for them, okay? We call this the base, all right? Both of them are called bases, all right? So that's a base and that's a base, all right? So the two parallel ones are called bases. I'll call this base 1. Guess what I'm going to call this one? Base 2. Very good. All right, so I'll call one base 1, the other one base 2, because they're not the same length, are they? You see that top one's a lot shorter than the bottom one. So they're not the same, but we still call them the base. All right, that's the two parallel ones. The two that are not parallel, we give names for that as well. We call them the legs. So that would be one leg, and this would be, let's make that L. And then that still looks terrible. Let's just make it like that, okay? So you got one leg and you got another leg. All right, these are the non-parallel ones, okay? So the ones that are not parallel are called the legs. The ones that are parallel are called the bases, okay? Because you got two of them. Everybody with me on that? All right, yeah, easy. No big deal. So I want to do a specific type of trapezoid. This is like your basic, everyday, normal trapezoid. Nothing special about it. It's got one pair of parallel sides, but watch this. I'm going to draw another one. I'm going to try to draw it a certain way. All right, see there's the middle. Well, actually, let's just do this. I want to get those middles to line up. That's pretty close. Maybe move this just a tad this way. Oops, wrong way. Okay. Now, what I'm trying to do, I'm trying to be specific on this. Okay, I drew two parallel sides, but I want this side right here, that leg, see that leg? I want it to be, what do you think? What do you think I was trying to do to these two legs? Make them equal. Exactly right. You got it. I was trying to make these two equal to each other. And we know that these are your parallel sides. These two are equal. Now, on an everyday normal trapezoid, like right here, this leg looks a little shorter than this leg. Wouldn't you agree? Okay, they don't look exactly the same, right? That one looks a little shorter than this one, but I tried my best to make these two legs to be exactly the same. We have a special name for this. Now, we're not going to do much with it in this lesson, but in another lesson, we're going to do some stuff with this, all right? So this is just getting you ready for another lesson, all right? If these legs are equal to each other, by the way, let me say this. A trapezoid has a lot of similarities to a triangle. I mean, in fact, they even start with the same letter. Even the first two letters, right? TR for trapezoid, TR for triangle. It kind of looks like it could be a triangle. Let me just show you this. Because there's a lot of similarities with trapezoid and triangle. In my honors class, we're in chapter 7, and we're finding the area of different things. Area of a rectangle, area of a square, area of a triangle, area of a trapezoid, area of a parallelogram, all kinds of different things that we're trying to find the area of. Area of a rhombus. All the stuff that we're talking about now, we're going to be talking about in the next chapter, but we're going to be finding the area of those things, okay? So that's why it's important to know these words, because you're going to see them again, not just in this chapter, but you'll see them again. But watch this. What if I extended that side right here and I extended this side? What's it starting to look like? Looks like a triangle, doesn't it? So there's a lot of similarities to a trapezoid and a triangle. It's kind of like a triangle, but you like whopped off the top of it, but you made it so it's parallel to this. Doesn't it look like that? Looks like you just cut that triangle. You made sure, though, that those two, you didn't cut it at an angle. You cut it exactly parallel to this side right there. So we talked about this. So when we had a triangle and you had two equal sides, what did we call that triangle when you had a triangle with two equal sides? We called it isosceles. Very good. So what do you think we're going to call a trapezoid with two equal sides? An isosceles trapezoid. So this one would be isosceles trapezoid. And what does that mean? To be isosceles, it's got how many sides equal? Two sides equal, okay? So it's the legs. It's the two legs that are equal to each other, not the parallel sides, but the non-parallel sides. If those two are equal to each other, then it's a what? It's an isosceles trapezoid. Very similar to isosceles triangle, right? Isosceles triangle, you had two equal sides. Isosceles trapezoid, you got two equal sides. Make sense? Yeah. Let's do an example. And once we finish this example, we should be done. I'm going to draw a couple things here. These two lines that I'm drawing right now, don't worry about those. I'm just doing it so I can give me a nice, perfect kite. I'm going to get rid of those two lines across each other like that. I'm going to get rid of those in a second. That just gives me a nice kite. There we go. See, look at that. Perfect. So that's a kite. What do I know about a kite? We talked about it earlier. 2 consecutive equal sides. That's right. 2 pairs of consecutive equal sides. So that means if this is a kite, that means that side and that side are equal. And what else? This side right here and this side right here are equal to each other. Everybody good so far? Yeah, it's just a kite. No big deal. But watch what they're going to do. They're going to put, let's do this in a different color. They're going to put some values. They're going to say this side right here is equal to 3 times, parentheses, y plus 2. And they're going to say this side over here is 5y plus 2. And then down here, they're going to say this one is x plus 5. And this one over here is 3x minus 1. This is an example. So where do you think you're going to see these examples show up? On the test, on a quiz, on the homeworks, okay? So this is the kind of stuff that you're going to see on a quiz or a test. Might not be this exact one, but it's going to be something very, very close to it. So the question says, find the measures. Let me write it down. You write it down as well. If you're not writing it down, you're not doing what you're supposed to be doing. So find the measures of each side of the kite. Okay, what does that mean? Yeah, we're going to do some algebra. You got it. Okay, what does that mean, find the measures of each side of the kite? That means we're going to find out the length of it, right? How long that side is. And with this information right here, we should be able to find the length of that side, and this side, and this side, and this side. We should be able to find all 4 lengths. So let's do the red one. You got it. That's the geometry. That's all the geometry you had to know. It's the only thing you needed to know about a kite was that these 2 sides are equal to each other. So guess what you're going to do here? You're going to go 3 times what?
3 times 2.
Well, we'll do that in a second. Equals what? 5y plus 2. Everybody with me? So this is equal to this. Do you agree? Because it's a kite. And this length is equal to this length, just because the definition of a kite. No. What do you have to do? Solve it. Right. Solve for y. But then, are we done after we solve for y? No, we got to do what? Plug it what? Back in. Plug it back in for y. So we got to find y, and then we're going to plug it back in either to this one or to this one. Doesn't matter. And then we can find the length of that side right there. Okay? So let's do it. What do we do first? What's our first step here? We're just doing algebra. What's this step called? Distribute. That's right. Okay, it's distribute. So let's do that. 3. That means you're just going to multiply that 3 times everything inside of here. So it's 3y plus 6. Do we have to distribute anything there? Nope. Just write it down. 5y plus 2. I'm going to go through this kind of quick, okay, because we've done a lot of this algebra before. What I would do, I would not subtract a 5y from both sides. Why not? Because if I subtract a 5y from this, I'm left with what? A negative 2y. You could do that. It would be okay. It's fine. But would you rather deal with a positive or a negative? Positive. Me too. All right, so what I'm going to do is subtract a 3y. Why? Because now what am I going to be left with? A positive 2y. Everybody see that? I just think it's just that much, tiny, tiny bit easier doing it that way. Now, I got my y's on the right side, so that means I got to get rid of this 2. How do I get rid of that plus 2? Minus 2. Right? We've been doing this all year long, haven't we? Yep. Cancels. 6 minus 2, 4. 5y minus 3y, 2y. These 2's cancel. One more step. Divides both sides by 2. What's y equal to? 2. 4 divided by 2 is 2. Is that my answer? Do I circle it? Is that what I put on my test for my final answer? No, because what do they ask for? The measures of each side, So I can plug that y in for this, or I can plug the y in for this. It does not matter. Let's do it to both of them just to see if it actually does work, okay? Put a 2 in for this y right here. So what do I got? I got 3 times what? 2 plus 2. 3 times 4, which is 12. So this length right here is how much? It's 12. What's this length then? Without doing any math whatsoever. This math is also 12. Let's just see if it is by putting in the 2. Okay, 5 times what? 2 plus 2 is 10 plus 2, which is 12. Exactly what it should have been. Did we have to go through that work, though, once we found the other one? No, we didn't. So this is also equal to 12. So this side is 12. This side is 12. Now we got to do the green ones. Does that make sense? Yeah, we've been doing this all year, haven't we? We've just been doing them with different stuff. All right, now we're doing it with a kite. All right, so what do we do here? What's true about those 2 green ones? They're equal to each other, aren't they? So let's set them equal. I'm going to put the bigger x first, though. Just makes it a little bit easier. So 3x minus 1 is equal to what? 5? X plus 5. You got it. X plus 5. All right, so these 2 sides are equal. So you set them equal to each other. And now we can solve for x. Subtract an x from both sides. Add a 1 to both sides. Those ones cancel. 3x minus x is 2x. And then those x's cancel. 5 plus 1 is 6. Divide both sides by 2. X is 3. Is that my answer? Do I circle it? No, I don't. I got to plug it back in. Which one do you think is the easiest one to plug it back into? The x plus 5, definitely. So what is that? That's 3 plus 5, which is what? 8. So that length is 8. Without doing any math at all, what's this one going to be? That's also going to be 8. And there you go. Those are my answers. I got 12, 12, 8, and 8. And that's how you do it. Can you handle that?
No.
I know you are. Pretty simple, isn't it? Yeah. It's not always going to be that easy, but on that one was pretty easy. All right, let me show you your homework. It's a little different than what the lesson plan says because I didn't get as far as I intended. By the way, I'm skipping example 3, and then we're going to go past example 3. So let me see, where did I put my... Okay, here it is. Section, we'll call it 6.1a. Okay, because we got to finish it up tomorrow. So 6.1a, and we're doing page 252. And you're only doing 1 to 13 instead of 18, okay? So I changed it a little bit from what's on the lesson plan because 14 to 18 is stuff that we haven't covered yet today. All right, but we've covered everything from 1 to 13. So that's what your homework is, 1 to 13. Okay? Should be pretty easy. I looked at it. I don't even know if there's any math that you have to do. I think it's just a matter of just looking at stuff and writing down answers. All right? So try it, though. Don't wait till tomorrow until I read off the answers. Guys, now you wake up. It would have been better if you were awake when I was teaching. Stop pointing to somebody else. Okay? Just take responsibility. Okay, good. See, now you're learning. All right, 1 to 13, that's your homework, and that's due tomorrow.